Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll be going through the 2018 physics exam, focusing on questions related to the magnetic field. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. The magnetic force acting on a wire carrying a current in a uniform magnetic field is the product of the magnetic field strength, the current, and the length of the wire. For this calculation, ensure that the length of the wire is in meters, and if given in centimeters, it must be converted to meters. The direction of the magnetic force on the wire is determined by the right-hand slap rule. To apply this rule, extend your right hand. Your thumb should point in the direction of the conventional current, your other fingers should point in the direction of the magnetic field, and your palm will indicate the direction of the magnetic force. In this case, the force is directed out of the page. A straight wire carries a current. This current should produce magnetic fields around this wire. The direction of this magnetic field is determined by the right-hand grip rule. Your thumb points to the direction of conventional current, and other fingers point to the direction of magnetic fields around this wire. An electric field accelerates a proton between two plates. The proton exits into a region of uniform magnetic field at right angles to its path, directed out of the page, as shown in Figure 1. The electric field between two parallel plates is uniform. Its strength, in volts per meter, Vm, is the voltage divided by the distance between the plates. When a proton passes through an electric field, its electric potential energy is completely converted into kinetic energy. You can use this relationship to calculate the proton's speed by substituting the known values for its charge and mass, as well as the electric field strength, into the relevant equation. When a proton enters a magnetic field, the magnetic force acting on it provides the centripetal force required to make it travel in a circular path. This relationship allows you to calculate the radius of the circular path by substituting the known values for the proton's charge, mass, speed, and the magnetic field strength into the relevant equations, and then solving for the radius. When a horizontal coil carrying a current is placed in a magnetic field, it will experience a torque that causes it to rotate. The direction of this rotation is found using the right-hand rule. Extend your right hand with your thumb aligned with the conventional current's direction, and your fingers pointing from the magnetic north pole to the south pole. Your palm indicates the direction of the resulting magnetic force. In this scenario, the downward magnetic force on one side Hg will cause the coil to rotate in a clockwise direction. If you replace a motor's commutator with slip rings, the motor will not rotate continuously in one direction. Instead, it will oscillate back and forth between its horizontal and vertical positions. This section covers magnetic fields, worth 13 marks and contributes to 10% of the total 130 marks. Multiple choice questions, 3 marks. Question 1 and 2, magnetic force. Use the right-hand rule to find the direction and magnitude of the force on a current in a magnetic field. The force is perpendicular to both the current and the field. Question 3, right-hand grip rule. Use this rule to find the direction of the magnetic field lines around a current-carrying wire. Point your thumb in the direction of the current, and your fingers will curl in the direction of the magnetic field. Short answer questions, 10 marks. Question 1 A and B. Proton in an electric field. A proton's electric potential energy is converted into kinetic energy as it accelerates. This change in energy can be used to calculate its final speed. Question 1C. Proton in a magnetic field. The magnetic force on a proton entering a magnetic field acts as the centripetal force, causing it to move in a circular path. This relationship allows you to calculate the radius of the path. Question 3a. DC motor operation. A DC motor's commutator reverses the current every half turn to ensure continuous rotation. Question 3b. Commutator versus slip rings. Replacing the commutator with slip rings would prevent the current from reversing, causing the motor to oscillate back and forth instead of rotating continuously. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.